Welcome to Rajavali Education Channel. In this video, we are going to see how to solve this example 3.6 from the chapter 3, 12th NCERT Physics. The question is, determine the current in each branch of the network shown in the figure. First, we have to find out I1, I2, I3 individually. For this, we have to use Kirchhoff's second rule or voltage rule. First, we consider this BCDEB loop. This is the current direction for this loop. Voltage rule is very simple rule. I give one trick for this voltage rule. If the loop direction and the current directions are same, give positive sign for that voltage. And loop direction and the current directions are in opposite direction, give negative sign for that voltage. So first, considering for this resistor, the voltage is positive because this is the current direction and this is the loop direction. Both are in same direction. So we give positive sign here. Here also the current direction and the loop direction are same. So we give positive sign for this resistor. So the equation that sum of these two voltage is equal to this battery value, that is 5. So the equation is 2 into I2 plus I3 plus 2 into I2 plus I3 minus I1 is equal to 5. Expanding this equation, we get this one. 2I2 plus 2I2, 4I2, 2I3 plus 2I3, 4I3 minus 2I1 is equal to 5. So first value should be positive. So multiplying this value by negative sign, we get this one. Okay, let's consider this is equation 1. Next, we consider this loop, that is ABCA loop. Here, the current direction and the loop directions are same in all the resistors, that is in 3 resistors. So all the voltage value should be positive, that is equal to 10. This is the equation. 4 into I2 plus 2 into I2 plus I3 plus 1 into I1 is equal to 10. Expanding this equation, we get this one. So 4I2 plus 2I2, 6I2 plus 2I3 plus I1 is equal to 10. Rearranging this equation, we get I1 plus 6I2 plus 2I3 is equal to 10. Let's consider this is the equation 2. Next, we consider this ADCA loop. So here, this is the loop direction and this is the current direction. For this and this resistor, both loop and current directions are same. But in this case, this is the loop. The current direction is downward direction, but the loop direction is upward direction. So for this voltage, we should give negative sign here. Okay, so the equation becomes 4 into I1 minus I2 minus 2 into I2 plus I3 minus I1 plus I1 1 into I1 is equal to 10. So expanding this equation, we get this one. So 4I1, 2I1 plus I1, it is equal to 7I1. Next, minus 4I2 minus 2I2 minus 6I2. So 7I1 minus 6I2 minus 2I3 is equal to 10. Let's consider this is equation 3. Now we have 3 equations. Next, we have to solve these 3 equations. So adding this 2 and second and third equation, we get 8I1 is equal to 10 plus 10, 20, because these two values will be cancelled out. So I1 is equal to 20 by 8, that is equal to 2.5. Next, we multiply the second equation by 2, that is equal to 2I1 plus 12I2 plus 4I3 is equal to 20. Then adding this equation with the first equation, we get 4I1, this plus 4I3 and minus 4I3 will be cancelled out. So 4I1 plus 8I2 is equal to 50. Next, we substitute this I1 is equal to 2.5. Substituting this 2.5 instead of I1, we get this one. 4 into 2.5, 10. That is 10 plus 8I2 is equal to 50. Bringing this 10 here, we get 15 minus 10 is equal to 5. So 8I2 is equal to 5. I2 is equal to 5 by 8. Now we have I1 and I2 values. So substituting these two values in any one of the three equations, we get I3 value. I am going to substitute this I1, I2 values in second equation. So substituting these values and multiplying by taking LCM and simplifying the equation, we get this one. That is 20, 6 into 5, 30, and LCM value is 8. So multiplying this 8 into 2, 16, and bringing this 8 to right side, we get 80. So 20 plus 30, 50. 50 plus 16 I3 is equal to 80. 16 I3 is equal to 80 minus 50. Because bringing this 50 on right hand side, we get minus 50. So simplifying this value, we get 30. 16 I3 is equal to 30. So I3 is equal to 30 by 16. Simplifying this value, we get 1 into 14 by 16, and simplifying this 14 by 16, we get 1 into 7 by 8. Now we have I1, I2 and I3 values. Next we have to find out current in every branches. So in AB branch, I2 current is passing, so the current value is 5 by 8. Next branch is CA branch. Here I1 current is passing. The value is 20 by 8. Simplifying this value, we get 2 into 4 by 8. So 4 by 8 is equal to 1 by 2. So 2 into 1 by 2. Next branch is CD branch. Here I2 plus I3 minus I1 current is passing. Substituting these values, we get this one. 5 by 8 plus 15 by 8, 20 by 8. So 20 by 8 minus 20 by 8, 0. So across CD, no current is passing. Next branch is AD branch. In AD branch, the current is I1 minus I2. Substituting these values and simplifying, we get 15 by 8. Simplifying these values, we get mixed fraction, that is 1 into 7 by 8. Next branch is BC branch. In BC branch, the current is I2 plus I3. Substituting these values, we get 20 by 8. So that we get 2 into 4 by 8. Simplifying this 4 by 8, we get 2 into 1 by 2. Next branch is DEB branch. Here I3 current is passing. I3 value is 1 into 7 by 8. Now we found current in all branches. Next we check Kirchhoff voltage rule. So for this we consider this BADEB loop. Here in this case the current and the loop directions are opposite direction. Here the current and loop directions are the same direction. So we give negative sign here, we give positive sign here. Sum of these two values is equal to 5 volt. So that is equal to minus 5 by 8 into 4 plus 15 by 8, that is this value is equal to 15 by 8. 15 by 8 into 4 is equal to 5. 4 by 8 is equal to 1 by 2. So minus 5 by 2 plus 15 by 2 is equal to 5. Adding these two values, we get 10 by 2 is equal to 5. 10 by 2 is equal to 5. So 5 is equal to 5. Bring this 5 here, we get 5 minus 5 is equal to 0. Hence, Kirchhoff voltage rule is verified. I hope you understand the concept very well. Thank you for watching.